Coring, or as it is sometimes referred to as aerification, is a mechanical means of relieving soil compaction, providing channels or holes into the soil to improve air and water movement. Often, too, it is used in conjunction with top dressing to help control thatch or organic matter. Here is a more complete list of the benefits associated with coring. This schematic shows what I consider the classic and most popular means of coring. The cylinder-looking components in this picture are called tines. These tines are hollow, and as they are pushed into the turf and then removed, a soil core is ejected onto the surface. Commonly, these tines have a 1/2 to 3/4 inch diameter that penetrates the soil to a depth of 2.5 to 3 inches. Why 2.5 inches to 3 inches? Because in most turf situations, soil compaction occurs in the top 2 to 3 inches of the soil profile. This gentleman is holding a handmade coring device that is manually pushed down into the green, for example, and pulled out, ejecting a soil core. I saw a similar device in use in Africa, a brutal job. This is a close-up of the pattern. On most coring devices, the tines are on a 2 by 2 inch spacing, but more on that in a minute. The more mechanical units that work the tines vertically up and down are like this one. One of the most popular coring units is shown here, and you can see the up and down movement of the tines and the ejection of the cores. Some of the coring units are developed for fairways, like this one, or like this one. The second type of hollow coring tine is the spoon, which are mounted on a rotating drum, as shown here. Notice the number of tine holes being created per given area are less than with the more vertical up and down motion of the previous machines. This table shows the relationship between tine diameter down the left side and tine spacing along the top. Both the tine size and spacing is given in inches. The common or classic way of coring is to use 1/2 or 3/4 inch tines, mainly 3/4 inches tines, on a 2 by 2 inch spacing, which for example on a putting green accounts for about 11% of the total surface area. Now you can see by changing the tine size or spacing, the impact is significant. Although 11% does not sound like a large amount, visually it is. As you can see from this lady golfer, she is not asking this young worker how his family is doing. To golfers, coring is the most hated practice done on a golf course because it interrupts play and disrupts the putting surface. Once cored, these cores may be removed or reincorporated back into the turf. On greens, core removal is the most common practice. Core removal on tees is also common. Besides removing cores by hand, there are mechanical means to push cores off a green, which is shown here. A blade is mounted in front of a triplex greens mower. On larger areas like fairways, there are machines like this and this to remove cores. Removing cores is often done in conjunction with top dressing. The amount of top dressing required is the amount needed to fill the holes. Hand brushing the sand in is labor intensive and not done on the vast majority of golf courses. But it is probably the most effective. More commonly, the top dressing is spread, which will be talked about more in the section on top dressing, and then brushed in. And after coring and top dressing, the turf is often rolled. One of the problems with sand top dressing is the sand particles can be mowed off, causing damage or dulling of the reels. So rolling after top dressing has been demonstrated to work more of the sand down into the canopy. Cores can also be reincorporated into the turf. On golf courses, this is normally done on large areas like fairways, and not done so much on greens, for the disadvantages listed here. Cores are commonly reincorporated back into the turf, as shown here pictorially. Verticutting units are often used to chop up the cores, and then they are drugged back into the turf. This is a verticutting unit. It replaces the cutting unit on a mower, and through the turning of the blades, it is used to remove thatch and organic matter. Here are vertical units on this triplex mower being used to remove thatch from a fairway. It can also occur on greens. From the previous pictures, compared to this one, the intensity of verticutting can vary. As previously mentioned, these verticut units can be used to chop up cores, and normally a drag mat is used or run across the turf to work the soil back down into the turf. A version of traditional coring method is to use smaller diameter tines, maybe a 1/4 inch in diameter, on a closer spacing. In this case, they are using smaller tines and going across the turf twice. This practice is called quadrutining. Most quadrutine operations consist of doubling the number of tines on the machine arm, like this. The depth of these tines can be varied too. Oftentimes the depth at which you quadrutine is much shallower than what you would do with the classical or common coring. And while we've talked about hollow tine, the ones that eject a soil core, there are tines that are solid, known as solid tines, which is shown here. These tines are referred to as star tines. Here is a version of quadrutining with pencil tines. Quadrutining is often done during summer months to increase soil gas exchange with minimal disruption to the turf. Quadrutining during the summer is sometimes referred to as venting. I thought I would end this discussion of quadrutining with this unit that was being used on a golf course in Southeast Asia. I guess you can walk across the turf coring and what looks like with solid pencil tines. Actually, these are nails. This is not effective and must be a real killer on the feet. In some situations, coring beyond the 2.5 inch depth is desired. Drilling or deep tining are done for deeper soil penetration. The concept of coring to a deeper depth has been around for a while. This picture shows a coring unit using tines that are actually drill bits. This picture was taken in the early 1960s. Deep drilling was initially done by hand, shown here with a drill and a long drill bit. The piece of plywood acts as a template for drilling. This type of practice was not only hard on the drill bit, but on the operator. Now there are mechanically drilling devices which are available. Drilling in combination with filling the holes with sand is popular. The term drill and fill is often used when drilling is done in conjunction with filling the holes with sand. The deep drilling, or coring, is a slow process and is disruptive to the turf, so it's often done in late fall. Solid and hollow tine machines are also available that can punch holes deep into the profile. Deep tine coring is normally done with solid tines and is done again to get better water movement through a compacted soil profile. I wanted to finish up with a couple of practices for relieving soil compaction that are not normally considered coring in the traditional sense. The first is water injection, which was developed by the Toro Company in the early 1990s. They called their device a hydroject, and basically you injected water at 2500 psi into the root zone. Depending on the speed of the machine, you could vary the depth of penetration. When this water was injected down in the root zone, it shattered the soil, which you can see by looking down into this cup. Notice too that little if any disturbance to the turf occurred. The machine at the time cost approximately $20,000, but were quite popular. Actually, with this unit, people would go out weekly and use it. But research found that the root hairs were damaged and root hairs needed 21 days to recover. Thus the reason venting is done on a 21-day basis. Toro does not make the hydroject anymore, and you really don't see them used. I don't know why, maybe they're too slow or whatever, but I still find them sitting around in maintenance facilities. So those that have them probably still use them to some extent. There is a version of the hydroject that is on the market currently. And generally you would contract this service. And it's called the dry-ject. Same principle as the hydroject. You inject water under high pressure into the turf, but in this case you're adding sand to the water. This is a dry-ject in operation, and the effect it can have, as you can see the sand inserted into the soil profile. There are other devices that are coming on the market to relieve soil compaction. This is a new one called coring2, which I don't know too much about. The principle is these probes are inserted into the root zone and then compressed air is discharged through them, basically blowing up the root zone, which causes fissures and such. I guess as long as soil compaction is an issue, there will always be new ways of trying to alleviate it. This concludes this presentation.